So question 13, it's quite a long question, but we do not get into doing the proof until we get to part C anyway. But question 13, A and B are probably going to help us just with remembering some trig stuff and just working our way into it. So in 13A it says show that 2 sine x multiplied by cos x plus 3 cos x is equal to sine 4x. Okay, so don't worry, I get it. We haven't done trig for a while. So we want to show that 2 sine x cos x plus 3 cos x is equal to sine 4x. So what are we going to do first?
Take out cos as a common factor.
No.
Well, multiply. Can you not do that?
No.
Expand the bracket.
Expand the bracket. But we're going to start with the left-hand side, aren't we?
Yeah.
We also, I didn't read out the question properly, but notice at the top it says we know that 2 sine x cos x is equal to sine 2x. So that's probably your first hint that we need to multiply through. Because if we multiply through, we're going to get that term straight away, aren't we? Because if we multiply this through here and then through here, we're going to get 2 sine x cos x plus, and I wrote that wrong there. Put my 3 in the wrong spot. Good job. Why won't you disappear? Okay, let's make this right. Cos 3x would be a bit better. So now we'll have 2 sine x cos 3x. Are we okay with that? Yep. What can we do on the next line?
Sine 2x plus 2 sine x cos x is equal to sine 2x.
Yep. So we know that from what was given to us in the question. So from this bit at the top. Okay, so 2 sine x cos x is equal to sine 2x plus 2 sine x cos 3x. Now, what can we do now? Because we're not there yet. We're still not at sine 4x. Bring out the rules. Let's see if we can find a rule. Which bit are you confused with, Javage? From this bit here. Hang on. Javage, from this bit here. Javage. Are you talking about this term here? From up here in the question, buddy.
Oh, I just used the rule.
It is a rule, but it was given to you
Oh,
in the question. Yeah, so that, as I said before, that should have been the biggest indicator that you needed to expand the brackets so you could get that.
We could use the 2 sine A cos
Yep.
B.
So let's say that this is sine 2x. Now Josh has found a rule. What are we going to have, Josh? You want to have a go?
Sine 2x plus by sine x plus 3x.
So sine x plus 3x. Yep.
And then a plus by sine x minus 3x.
Perfect. Can everyone find what rule we just used? So what I did was put extra brackets around it to try and show you that this bit here has become this bit here. Okay, I don't have mine in front of me because I've had to borrow it out, but I think it's in red and it's the second one from the bottom.
Yes.
Yep. So you should say, yeah, 2 sine A cos A or something, or cos B.
Yep.
Yep. So the 2's obviously there. This is the x is A and the 3x is B. Does that make sense? Yep. Now, what can we do on the next line? What are we going to do now? What's sine x plus 3x going to become?
Sine 4x.
Sine 4x. And doesn't that make us feel a bit better? Because we want a sine 4x and all of a sudden we've got one. And what's the last one become? Sine minus 2x. Now, why do they cancel? Well, no, I've got a sine negative 2x. I don't have a negative sine 2x. Good. So then we can say that we've got sine 2x plus sine 4x is equal to, minus sine 2x. Because we know there's that rule that was sine of negative theta is equal to negative sine theta. These will cancel, will they not? It's equal to sine 4x, which is the right hand side, so we can be pretty happy. Cool. Yeah. We're just leading into the induction. We okay with that part?
Yep.
So guys, you might still be going, but if you follow the same process from what we did for part A, you should be all good, yeah?
Yes.
Yeah, and you can use what you did in part AI to simplify it a little bit more. Instead of having to show all the working again from AI to get that first part. Does that make sense?
When it says predict, do we have to do any maths behind that? Or?
You could just try and say what your answer is. So if you guys want to jump on and start having a look at B, you can have a go at that. I think BI is okay. I and I are also quite easy. You've just got to see the trick. Good. You can then start the induction if you like. Okay, guys, can someone tell me what the answer is for BI?
Yes, sine 6x.
Are you sure it's sine 6x?
No. Yeah, 8x.
Which
My
one?
guess.
Oh, BI.
BI.
8x.
So it's going to be sine 8x because we're going to follow on with that pattern, aren't we? So before in AI we found sine was equal to sine 4x and it was sine 6x. Following that pattern we're going to get sine 8x. Now what about in BII? What are we going to do in that one?
Oh my god. Wait, 10
What?
terms meaning like cos.
Yeah.
Cos
What?
X is 1, cos 2
Mhm.
is 2. Oh.
Well, no, it's x, 3x, 5x up to 19x. It's 10 terms. So what about if I wrote this out?
Oh, I see the pattern. It's always the last cos X plus 1.
So what's that equal to?
Cos 20.
20x.
Now have we finished the question?
No.
Predict? Yeah.
Why have we not finished the question, Ishan?
Because it's n.
No. Have we finished BII?
Yes.
No,
Oh, no.
Wait, isn't it sine?
it is. I'm writing because I just wrote so many. Now, why haven't we finished part BII? What did BII actually ask for? It didn't ask for this 2 sine x in front of it. Did it not?
It just says predict what it will be.
Predict this one. Now, the one above had 2 sine x in it. Everything else we've looked at has had 2 sine x. So we could do that. So what's this then equal to? So what's BII actually equal to?
20x.
No.
Oh, no.
Sine 20x divided by 2 sine x.
Perfect. Sine 20x divided by 2 sine x. Yeah, just that, good old
Oh, yeah.
algebra. But also hard to see in the beginning. That's very fair. So that's equal to sine 20x over 2 sine x.
Can you
right.
actually simplify that or not?
So we okay with that?
And it's
Yeah.
on 10, sine 10.
No. All right, so what is then BIII?
Would be sine n plus 1x. On sine 2x.
Okay, before we start, let's talk about that last term there. So we've got this cos 2n minus 1x. Why is it 2n minus 1? Why do we have 2n minus 1?
Because it's an odd number.
Because, yeah, odd number.
Odd number. So we need to times by 2 and then take 1 gives us an odd number. Now if we're looking at the pattern at the moment, so we've got this last number here is a 7. Here we've got an 8. Last number here we've got a 19. Here we've got a 20. Okay, so what does that mean? If you've got 2n minus 1, what's that top line going to become?
2n.
So sine 2n x, right?
On sine 2x.
On 2 sine x.
Oh, is it because it's 20 minus 1 plus 1?
Yeah, so this is minus 1 here.
Yeah, right.
And see how this one is a 19
Yeah,
and then
it's
it's a
one
20.
more.
So it's
Yeah,
one
yeah,
more.
yeah.
So does that make sense?
Yeah.
Okay, so what we've just essentially done is found our own little sequence, more or less, to then help us with the induction step in part C. All right. Are there any questions for that bit?
No.
Are we wanting to start this wonderful induction?
Yep, 9.
Okay, so how are we going to start C? What's the first thing we're going to do?
Write the if this is
Basis.
P, no, basis.
Oh no.
No, you write the
PM
whole thing
is-
like.
Pn is good.
Yeah.
We need to make sure we've got that. So cos theta plus cos 3 theta plus cos 5 theta plus
Sigma thing.
cos 2n minus 1 theta is equal to sine 2n theta on 2 sine theta for all n within positive integers. Whew. Okay. Next step.
N equals 1.
So if n is equal to 1, that's a 1. What's the left-hand side equal to?
One.
Sine
Oh, we have to
No, left-hand side. Left-hand side.
Cos 2 to 1.
Nope.
Where's the?
Cos theta. So remember this n equals 1 is talking about the first term. You don't need to find the 1, it's just the first term. So the left-hand side is cos
the
theta.
cos one.
Yep. What's the right-hand side then?
Is that not the last term? But you sub in for
It's
one.
just 1. Right hand side equals 1 as well.
2 times 1.
No,
minus
we
one.
don't want the right-hand side to
Yeah.
equal 1.
No,
Okay.
it's cos and then bracket 2n minus 1. But
Hang
you
on, hang
sub
on,
one
hang on,
for
hang on,
n.
hang on. Let's just, I know we've just put trig in here and that can then cause a bit of confusion, but let's just think back about what we're doing. And I know in 7 and 8 and 9 it kind of changed up the process. But remember when we were looking at n is equal to 1, we look at the first term on the left-hand side. Then with the right-hand side, we look at this bit here. Okay, and all we're doing is we're subbing in 1
For n.
where n is. So we're going to have sine 2 theta over 2 sine theta. And we now need to manipulate that to get it to equal cos theta.
Or you could do the 2 sine x cos x on the top bit.
Wow, I just got rid of half of that.
Things.
What was that?
I said you can make the 2 sine 2x equal 2 sine x cos x.
Hang on, you're talking about x's. We're talking about thetas.
2 sine theta.
Yep,
Sine 2 theta equals 2 sine theta cos theta.
perfect. 2 sine theta, cos theta.
Then you
Cos
cancel the
theta
2
equals
sine
1.
thetas.
No, why are we making anything equal to 1?
That's what it said, didn't it?
No, we need to make it equal to the, we need it to equal the left-hand side.
Oh,
So cos theta.
yeah.
So we're good.
Isn't that the first term, cos theta?
Yes, that's why when n is equal to 1, that's why we're saying the left-hand side is equal to cos theta.
Cos theta is equal.
No, we're not saying cos theta is equal to 1.
Oh, it
N
is
is
term
equal to
one.
1, so it's term 1. Yeah.
Mm.
So then we can say that P1 is true. We okay with that? The next step then.
PK.
So if PK is true, then cos theta plus cos 3 theta plus cos 5 theta, and I'm going to stop there. I'm not going to be able to fit it all in. Cos 2k minus 1 theta is equal to, I'm going to erase this because it's going to get messy. So this is definitely one where you probably don't want to have a line in the middle of your page. Cos theta plus cos 3 theta, let's skip a term. Cos 2k minus 1 theta is equal to sine 2k theta over 2 sine theta. Okay, now don't get sucked into changing your thetas to a k. When I first did this question, I changed one of my thetas to a k. I can tell you it didn't go very well. Definitely didn't. Anywho, what are we going to do now? What's next?
PK plus 1.
Yep, so then we can say that cos theta plus cos 3 theta plus cos 2k minus 1 theta plus, now what's that going to become in this one? If we've got 2k minus 1, but now the k is going to become plus 1, what's going to go in that in those brackets? 2k
2k theta. 2k minus. No.
So remember, if we look at this one here, we've got to add k plus 1 to this point here.
It's 2k.
Yeah, it's 2k.
No.
2k plus 1.
So we 2k plus 2 minus 1 is equal to 2k plus 1. If you rush that and get that wrong, it means it will not work. Okay? It will not work. And then you'll be sitting there going, why is this not working? Which is totally understandable. Which is what happened to me, not in regards to that step, because I got that step right the first time I did this, but I changed a theta to a k. Now, why you changed a theta to a k, I've got no idea, but it's what I did at the time. So don't change a theta to a k. Does it make sense now, Javaj, and why it's 2k plus 1 though? Yeah.
It's just,
Yeah, it makes
it's just
more
it's
sense.
straight.
That's
That's
right.
right.
It's understandable.
Yeah. So if you want to, what we'll do then is
That's
we'll
what I did.
do an extra step. It means if we do an extra step, you're obviously going to be writing more, which is fine. But if we go cos 2k plus 1 minus 1 theta is equal to, now we're not even going to fit it. So let's just go down here. So cos
Mine just fit.
3 theta plus 2k minus 1 theta plus cos. Now we can change it, so it's going to be 2k,
Plus 2 minus 1.
but I'm just going to go to that, because otherwise we're going to have to rewrite it again. And then that's going to become sine 2k plus 1 theta on 2 sine theta.
Oh, I feel already.
So then this is going to become, that's how we get it from that to that. Okay, let's simplify that right hand side a little bit. What could we write that as? Sine 2k plus 2 theta over 2 sine theta.
Wait, how do you do that? Oh, okay.
Could we then multiply the theta in as well?
Yes.
So we could say it's sine 2k theta plus 2 theta, right?
And then
Over 2 sine theta. So that's what we're now attempting to find. That is our right hand side, and now we've got to go to the left hand side.
Just a quick question, mate.
Yeah?
Can't you do the sine 2k theta plus 2 theta? Don't you use a rule there?
You can, but let's not do that. Because otherwise then we're going to be manipulating the right hand side too much. Let's just leave it at that point. You could if you wanted to. Okay, so let's just now say what's our left hand side going to equal, and then I'll go to a new slide. So our left hand side is going to be this bit, isn't it? Because this bit is going to sub in for this first section. So this bit, oh, I can't fit it anymore. Oop. Yep, you probably will. This is a long question. So remember, if we're looking at this bit here, this sine 2k theta is equal to this part here, isn't it not? So we're then going to have sine 2k theta over 2 sine theta plus cos 2k plus 1 theta. All right? Let me know when we're all good to change slides. And if you want to start, you can start having a go to see if you can get to this. What are we going to do now? What would be your first step if you looked at
I
this?
don't know, like, multiply the theta instead of the cos.
Just get them over the same denominator.
Yep, so either one of those would be fine. You could multiply the theta in with the cos, or you can multiply by the common denominator.
I did not do that.
So I'm going to multiply by the common denominator first. It does not matter which way you do it. So I'm doing it like that. That's then going to make it sine 2k theta plus 2 sine theta cos 2k plus 1 theta all over 2 sine theta, right?
And then
I wrote that wrong. I wrote 2 sine theta cos 2 theta. I wrote cos.
is the sine 2k theta cos 2k theta, does that equal 1 when you add them together?
Which one?
I'll just say when you
Yeah, okay. So now hopefully you can see, all right, we've got one point or part that's right. Let's do this bit and this bit. Woo! Woo! Okay. Now, Ishan, do you want me to multiply in the theta? I didn't actually multiply the theta in, I don't think, originally, but that's okay. Because it will probably make it easier anyway.
For the 2 sine theta cos. That's fine.
So you want to say that bit?
No. I was gonna say 2 sine theta cos, and I realized it wasn't cos theta because I thought like.
All right.
You can change you can do the rule thing with the.
Yeah.
Cos.
So we okay with that step? Is there any questions on what I've done in those first 2 steps?
Just wait.
Okay. Waiting. So red rule, second from the bottom. So sine 2k theta. Now, what's that 2 sine cos, or 2 sine theta cos blah, blah, blah? Is going to become
Sine 2 theta.
sine theta plus 2k theta plus theta plus sine theta minus, now remember to put this in brackets, 2k theta plus theta. It's a rule. Guys, it's the exact same rule we used in part A. The exact same rule we used in part A.
Did I say that way?
Exactly the same. So when you've got 2 sine theta cos theta, this bit here is A, this bit here is B.
That is amazing.
That's what it
I
is.
just don't like it.
I did warn you that these were going to be hard, and I was hoping we could do this at the start, because then we'd have the rest of the double to do the one other question I wanted you to do.
Which is?
14.
Okay.
Now I'm gonna expect you to try and do it for homework.
Oh.
That's not too much.
Okay.
That's going to divide really nice.
Right, guys, you're about 2 steps away.
Are we allowed to like cry?
No,
Are we gonna get judged?
no, you're not crying. Where, Javaj.
We're there.
Okay, so we've got sine 2k theta plus sine 2k theta plus 2 theta. And then shouldn't we be happy, because I'm pretty sure that's what was on the top of what we wanted, plus sine negative, what have we got, 2k theta, and these will cancel, because that negative will multiply through by both.
Whoa, what? Wait, what happened there?
Hang on. Again, guys, I know we do this often. We need to, if one person has a question. So this bit here, it's just algebra. Theta minus 2k theta plus theta. We're multiplying that minus in. So it becomes theta minus 2k theta minus theta. These will cancel. Okay? Make sense?
Yep.
Now what can we change? What can we do with this one?
That's the same as the first one.
Cancel the first thing with the that.
Hello, let's get more descriptive.
We can, yeah. There you go.
So you can make it minus because of the same rule.
Is everyone in here?
2 sine theta. These will cancel. So now what have we got?
You have the first.
Whoa, why is not everything moving?
You have what you want to prove now.
Are you not doing it?
So then we're left with sine 2k theta plus 2 theta over 2 sine theta, which is the right hand side.
Yeah.
And then we have to write that since P1 is true.
Oh my God, we're not writing that.
You are writing that. You don't write that. I'll dock you marks. And that will, well, I'm not going to dock you marks, so I don't mark with marks, but it will affect your performance standards.
If you were to mark with marks.
It would be at least a mark every time you don't do it. That's what the year 12 teacher did to the year 12s this year.
Write the sentence that we have.
And all the year 12 had.
Yep.
Do you expect next year or you don't know?
You guys will probably know before I know.
Love that.
Really?
I don't know. This is my first year at the school. I don't know how the process works, so I don't know when I'll know.
It's our first year in this grade.
Yeah, but first day
Same
back.
thing.
Yeah, but yeah, I don't know. And I. What was that? So there is that question. Obviously, that one was long.
This is a page 4 question.
14 isn't as long, and I was only going to ask you to do 14 for the trig stuff. Okay, so we have 13 minutes, so you might want to start 14 if you want. But I'd be suggesting between now and Friday, homework is to have a go at question 14. I don't mind if you don't get it, but I want you to have a go at it. And then there's another video on proof via Javaj. proof via divisibility. So we need to watch a video and we need to have a go at 14.
That video's already up, isn't it?
Yes.
Thank you.
This is one question.